Hey guys, so today you and I are going to talk about very few bugs, so let's get into it. So the question in question was, hi Frederick, what are the best approaches to write code with very few bugs? Well, there are a few tried and true patterns for how to do this, and I'll try to basically give you sort of the tips and tricks that I usually use in order to try to reduce it down to the bare minimum that I can sustain. So first and foremost, you need to understand automated testing. Hopefully that is a no-brainer for those of you who have been doing some professional work. Basically that means unit testing, end-to-end testing, if you have a UI of some sort, visual regression testing, etc, etc. There are many patterns for how to do this, but in essence it's good for you to take a look at the testing pyramid and have an understanding of whatever stack you're using, what is the general way that people use, like what are the general tools that your specific stack leverages in order to deal with bugs at different levels, because this is a very important factor. A bug is it's just unintended behavior at some part of the application that somehow affects the user experience. The reason why I say that, it might sound obvious, but it's actually very important, is that you have to understand as a software developer what layers of the application can fail and how do you assert that each individual layer is working as expected. This is very complicated, and the reason I can give you an example. So I was working with a developer of mine a while back. I asked this person was making an update to the base URL of an application. And so in the code review he had written unit tests, like had made sure that he had tested everything, in properly. All the end-to-end tests had been passing, and etc, etc. Basically the whole suite, and he had done quote unquote all the things that on a normal story he was expected to do. And then he pushes, he merges this code, sends it out into production. Boom, production issue immediately. The reason being what happens is that the update that he had made had not been checked with the operations team, which meant that the load balancer that he was basically behind, that forwards all the requests, was not updated, and so the routing wasn't happening correctly, which meant the whole application broke, because there was an environment in which he had not been tested before he released, which was the production environment. Now, I talked to him about this, and he said, "Oh well," because in this scenario he said, "Yeah, it would have been great if we had a QA environment or a test environment before we pushed this thing, so I could have tested it in that environment." And I went, "That wouldn't have helped you, because in this case it was a front-end developer." And I said the reason why it wouldn't have helped you was because when you would have pushed it to the QA environment, yes, very likely you would have seen a breakage and you would have seen that you needed to update the routing of this thing. But the question is, would you have known how to do that for production as well? You might have known that you needed to make the update for production as well, but how would you do it in this manner? Because in this specific manner, there was no way to synchronize the updates of the routing at the same time as pushing into production. In other words, there's a window where something is inconsistent. Either the routing is not going to work, or the application is not going to be updated. So something is going to be broken for a little window of time in theory, basically. And so what he and I started talking about was that, okay, so how do you safeguard yourself from not making a mistake like this? And I said, well, it's very simple. You have to understand how to, in this case, I can give you the short answer, feature flagging, basically, where you need to be able to do a blue-green type of deployment thing, where you need to be able to spin up a new version of the code, like basically have backwards compatibility, make sure that all the traffic hits the new application and then degrade the old one, because if you don't do that, you're basically in a situation where, as I said, you have temporary outage. And maybe that's fine, and in this scenario it wasn't a big deal, but that's the sort of thinking that you need to have when you're trying to figure out how to reduce the amount of bugs you have, because the bugs that bugs can happen in so many ways, and so it's really important for you to have an understanding of the impacts, like all the parts that make up everything from how you get the code from your laptop all the way into the production environment and when it's actually running in production. This takes years, and it's a full stack knowledge level that is required to do this effectively, to really do it effectively. I had another coworker the other day who made a update to the source code, was very happy with it, had written unit tests, etc., and then he pushed it. And luckily for us, we had automated testing that, in this case, it was a Docker container everything was running in. So the Docker container was trying to be run, and this is where you want to have something like automated testing before things go out into production, which in this case it was. So the container was trying to be built, and then it's frozen error because the change that he had made was only, the bug only existed. Basically, he had a routing problem, not a routing problem, he had a path problem to certain libraries, code libraries that he was depending on. Those code libraries were not being imported into the container correctly, so now the container broke. And when he made the change, he didn't think about that, because he didn't think about the next step. Okay, what happens when this thing goes into the next container? Now, this is the main reason why bugs happen, guys. The developers are forgetting about some execution environment, or like there might be a logical error, etc. So there's tons of ways for this to happen. But for you to understand how the testing pyramid has to work, you have to also understand all the things that are going to happen between you wrote the code in your on your workstation all the way until it's out in production, and what can possibly go wrong when it is in production, and apply the necessary fail-safes in order to deal with that problem. So as I said, unit test, that's what the junior learns. That's the first step, just to make sure that the thing that you just wrote doesn't like logically break somehow. Then the next thing is integration test. You need to be able to connect to systems or something like that to make sure that the system still works. Then you might have health checks, because something might, if something's running in production, you don't know, maybe there's an outage somewhere and some service goes down, and if you don't know about it, well, then it's down and your system is now, there's a bug, there's a temporary outage, etc., and then you have questions about, okay, so if now something breaks into production, how do you actually go back from that? How do you save yourself from that? That's where feature flagging, for example, can be an alternative. You can have multiple redundancies with this is one of the reasons why we recommend usually to have more than one availability zone or something like that if you're dealing with cloud providers, etc. There's tons and tons and tons of everything from rollbacks to redundancies to feature flagging to like backwards compatibility, like graceful degradation, etc. And in order for you to write as few bugs as possible, you basically need to know, as I said, how does the entire delivery look like, what can go wrong in production, and what are the remedies that you can apply in order to mitigate those sorts of problems. And I'll give you one more, which is a very important one. Make sure that the code that you are writing is simple. The reason why I say that, it might sound silly and like obvious, but the reason why I say that is because the simpler you can design the code, the less likely you are to create unnecessary complexity around the delivery process. If you have the option of picking something that is very simple, very stable, something that where you're basically just trying to keep down the complexity of what you're doing, that's almost always a good investment for you, because a lot of these, the more complex, as I was saying with these two examples, the more complicated your environment is, the more of things you have to keep in mind whenever you're doing the coding, because as you can imagine, it's almost impossible for you to sit there and go, yeah, I changed, an example would be, I changed the symbols here. Like I added a few. Classic one is German signs, or like something like a German characters or Chinese characters or something like that here in this little text here that's going to be translated. I wonder if we have the right encoding format in our database, which is another one that I've found as well. Like I've been working on projects where literally they have the wrong encoding format. They store things in the incorrect format and send it back to us. So all we get is this little, like, you know, the placeholder symbol for all of the non-UTF. I don't remember which encoding they were using, but basically it was like we had to show broken text to all of our customers from Germany, etc., etc., because they had not considered that this would have been a problem. So what I want you to take away from this is that the way that you write as few bugs as possible is, number one, you have to get yourself informed of the main testing tools you usually use. The common ones are, you know, unit testing, end-to-end testing, visual regression testing, feature flagging, things like that. But there's more to it, because I mean, guys, it's a whole education to learn all of this sort of stuff. This is sort of what the site reliability engineers and things like, you know, it's an entire job to master all of this stuff, right? But that is basically what it comes down to, because what you have to understand is that there is no, like the entire way from your laptop all the way up to how something is running in production can break. And the best way for you to reduce the amount of bugs is for you to create a gateway system where you know that you have a proven way to determine at each step of the delivery process if something is working, if it's working correctly, and some way to rectify the problem if something did not function correctly. So as I was saying, in production environments you have a few strategies. At the code level you have a few strategies, and there's tons of this stuff. But basically try to keep things as simple as possible, and then inform yourself about, alright, how do I make sure that all quote-unquote things that can go wrong with my code have been accounted for, and that there is some way for me to check if that thing is actually working. Unit test is a good start. Making sure that, you know, your containers and your production builds are working correctly, making sure that you have some type of way of checking the running code before it goes out into production is a good investment. Making sure that, as I said, visual regression testing or end-to-end testing, like features are working even in like a QA environment, doesn't have to be a QA environment. And then when things are in production, make sure that things are working in production. There's tons of different ways of doing that, everything from running end-to-end testing production to, you know, pinging things, or, you know, like doing feature flagging and turning features on and off, etc., etc. There's a whole, like, there's so much content related to this, guys, so I suggest that you have a look, but keep that fundamental thing with you. The most important thing is that you understand how your software, it goes from your laptop all the way out into production, and all the things that are happening as part of that process, because then you know what all the components are and how they in their unique way can fail you. Have a great day.